Today's class is about potential energy of a system of charges. First we will see potential energy of a system of two charges. Then we will generalize it for n number of charges. First we will see potential energy of a system of two charges. Potential energy of a system of two point charges. Now consider a system, and initially let us assume that there are no charges in the system. So consider there are no charges present initially in the system. Initially in the system. So when there is no charge, there is no potential at any point in the system, because the potential at any point is due to the electric field. So no charge, no field, no potential at any point in the system, and hence no potential at any point in the system. Let us say now we want to bring two charges from infinity to this system. So first we will bring a charge q1 from infinity to point A. Consider a point A in the system. Let charge q1 is brought from infinity to point A. So we initially we are considering a system with no charges, so hence potential at any point in the system is 0. Now let us say we are bringing a point charge q1 from infinity to some point A. So let us say in our system this is the point A. So initially potential at point A is 0. Since there are no external field, the work done bringing q1 to point A is 0. So our initial potential at point A is V A suffix A. V A equal to 0, because we do not have any charge initially, so initial potential at A is 0. So work done in bringing q1 from infinity to A is, therefore work done in bringing charge q1 from infinity to point A is W1 equal to q1 into VA. W1 is q1 into A. q1 into VA. So we know the work done is potential multiplied by charge. Because VA is 0, so this value is q1 into 0, so 0. So the initial work done when there is no electric field or there are no charges in the system. So the work done in bringing A from infinity to the work done in bringing Q1 from infinity to point A becomes 0 because there is no external field. Now, so we brought Q1 from infinity to, now consider another point B, which is say at a distance R12 from A. Consider another point B at a distance R12 from A. Point B at a distance R12 from the point A. R12 at a distance R12 from point A. The potential at B due to A is due to Q1 at A. Potential at B due to charge Q1 at A is given by VB equal to we'll write here potential at B due to charge Q1 at A is VB equal to one by 4 pi epsilon naught into Q1 divided by R12. So this is potential due to a point charge. Now if I want to bring a charge Q2 from infinity to point B, the work done will be given by Q2 into B. So let us say we are bringing another charge Q2 from infinity to point B. Work done in bringing another charge Q1, sorry not Q1, Q2 from infinity to point B is W2 equal to Q2 into VB, which is equal to 1 by 4 pi epsilon naught into Q1 Q2 divided by R12. So therefore the total work done in bringing 2 point charges, total work done in forming the system, total work done in forming the system of 2 point charges Q1 and Q2 is W equal to W1 plus W2. We know W1 is 0 plus 1 by 4 pi epsilon naught into Q1 Q2 divided by R12. And we know the work done gets stored in the form of potential energy of the system. The work done gets stored in the form of potential energy of the system. Therefore, potential energy of the system of two charges Q1 and Q2 is two charges Q1 and Q2 is U equal to 1 by 4 pi epsilon naught into Q1 Q2 divided by R12, where R12 is the distance between Q1 and Q2. If we have 2 point charges like this, Q1 Q2 R12, the potential energy of the system of two charges is 1 by 4 pi epsilon naught into Q1 Q2 by R12. Now we can generalize this for n number of charges. Now we have two charges Q1 and Q2 and they have red point A and B. Now consider point C. We know the distance between A and B is R12. Consider point C such that the distance between A and C is R13 and distance between B and C is R23. R23. So consider point C as shown in the figure. Now potential at C due to Q1 and Q2 is electric potential at point C due to Q1 and Q2 is Vc is equal to 1 by 4 pi epsilon naught into Q1 by R13 plus Q2 by R23. So this we have considered the potential due to n number of charges. Now if you want to bring another charge, say Q3 from infinity to point C, then what will be the work done? Let us say we are bringing another charge Q3 from infinity to point C. Therefore, work done in bringing Q3 from infinity to point C as W3 is Q3 into Vc. So this is equal to Q3 into 1 by 4 pi epsilon naught into Q1 divided by R13 plus Q2 divided by R23. Simplify this. W3 equal to 1 by 4 pi epsilon naught into Q1 Q3 divided by R13 plus Q2 Q3 divided by R23. So the total work done in forming a system of 3 point charges Q1, Q2, Q3 will be total work done in bringing or in forming a system of 3 point charges Q1, Q2 and Q3 as W equal to W1 plus W2 plus W3. W equal to, so W equal to 1 by 4 pi epsilon naught into Q1 Q2 by R12 is plus Q1 Q3 divided by R13 plus Q2 Q3 divided by R23. Therefore, potential energy of the system of 3 charges is equal to this work done, because work done gets stored in the form of potential energy. Therefore, potential energy of system of 3 charges Q1, Q2 and Q3 as U equal to 1 by 4 pi epsilon naught into Q1 Q2 by R12 plus Q1 Q3 divided by R13 plus R23. So the same formula you can, this is U, same formula you can extend for n number of charges. 1 by 4 pi epsilon naught into Q1 Q2 by R12 plus Q1 Q3 by R13 plus Q2 Q3 by R23.